This section 2.5 is about multiplication of matrices. In this section we'll learn how to multiply two matrices. But before that, let me remind you of another multiplication that we learned last time. We learned about scalar multiplication. For scalar multiplication, we multiply a matrix by a number. For example, number 5 is multiplied by the matrix 1, 2, 3, 4. Now, how to multiply a scalar? Scalar is a number. So if we multiply a number by a matrix or scalar by a matrix, that means we multiply each element of the matrix by that number, and we get, for example, here 5, 10, 15, and 20. Now in this section we'll learn how to multiply two matrices, not a scalar by a matrix, but two matrices. But there is a condition on that. That's possible if number of columns of the first matrix is equal to number of rows of the second matrix. I mean, the order of A is M by R, for example. The second matrix is R by N. As you can see, number of columns of the first matrix is equal to number of rows of the second matrix. So the inner numbers are the same. If number of columns of A is equal to number of rows of B, I mean the inner numbers are the same, then we can multiply. Now the resulting matrix C has order of M by N, or size M by N, the outer numbers. The outer numbers are M and N. Now let's take an example. In this example we are given two matrices A and B, a row matrix and column matrix, and we want to see if A times B is possible first, and then we find it if it's possible. So what is this process operation possible, A times B? Let's see. What is the rank of what is the order of the matrix A? The order of the matrix A is one row by 4 columns. And what is the order of B? The order B has 4 rows and 1 column, so it's 4 by 1. And now we look at number of columns of the first matrix and number of rows of the second matrix. The inner numbers are the same, so yes, it's possible. Now how to multiply matrices. Now the resulting matrix will have order 1 by 1. I mean just one element entry, 1 row and 1 column. That means only 1 entry. So how to find that? Now the multiplication of matrices can be done this way. So we have 1, -2, 3, and 5, and B is 2, 3, 0, -1. In order to multiply them, we need to know the order of the resulting matrix. It's 1 by 1. So just one element. So 1 by 1. And then we multiply each corresponding elements. 1 by 2 is equal to 2. And then we add, plus the second is -2. The corresponding element is 3. -2 times 3 is -6. And then we add. Then we have 3 times 0, 0, plus then we multiply 5 by -1, and that gives -5. So this is just one entry. So we find this entry. This is 2 minus, plus minus is minus, 2 minus 6 is -4, plus 0 is -4, minus 5, -9. So this is 1 by 1 matrix. This is how we multiply matrices. But this is a very simple case. We'll see matrices that involve more than 1 row and more than 1 column. Let's take another example. For example, if A is 3, 1, 4, -1, 2, 3, and the matrix B is 1, 3, -3, 4, -1, 2, 2, 4, 1, and we want to compute A times B if possible. So we first check the orders or the size of each matrix, and we want to see if number of columns of the first matrix is equal to number of rows of the second matrix. So matrix A has order or size 2 rows by 3 columns, so it's 2 by 3, and the second or matrix B has 3 rows and 3 columns, so it's 3 by 3. Now we look at the inner numbers. As you can see, those are equal, so yes, it's possible. Now since it's possible, now we need to find the product, A times B, the multiplication. Now the resulting matrix has order 2 times 3, the outer numbers, the 2 times number of rows times number of columns of the second one. So 2 rows and 3 columns. 2 rows and 3 columns. Okay, now how to multiply? We multiply the first row by the first column. This will be written here, or we put it here. So how to do that? As we did in the previous example, we multiply the corresponding elements. So 3 times 1 is 3, plus 1 times 4, it's 4, plus 4 times 2 is 8. So this is the first entry, and then we distribute this row over all the columns of the other matrix. Now we need to multiply it by the second column. We will distribute it over all columns of matrix B. So again, 3 times 3 is 9, plus 1 times -1 is -1, plus 4 times 4 is 16. And then we multiply it, the first row of A, by the third column of B. So we multiply 3 by -1, -3 by -3 is -9, plus 1 times 2, 2, 4 times 1, 4. We finish the first row. Now we distribute the first row over all columns of the second matrix. Now we do same thing for the second row. So let me choose another color. So we want to multiply this row, the second row, by the first column here. So we multiply -1 by 1. We just multiply corresponding elements, so that's -1, plus 2 by 4, 8, plus 3 by 2 is 6. And then we multiply it by the second row. So -1 times 3, -3, plus 2 times -1, -2, plus 3 times 4, 12. And then we multiply it by the second row of A, we multiply it by the third column of B. So we multiply -1 by -3, and that's -6, plus 2 by 2, that's 4, plus 3 by 1, which is 3. Now we add these numbers. So we have here 3 plus 4, 7, plus 8 is 15. Now here plus minus is minus. 9 minus 1 is 8, plus 16, 24. And here we have -9 plus 2, -7, plus 4, -3. Here -1 plus 8 is 7, plus 6 is 13. -3 minus 2 is -5, plus 12 is 7. And then -6 plus 4 is -2, plus 3 is +1. So that's the resulting matrix C. Now if you understand this process, you can apply multiplication for any order as long as the multiplication is possible. Now let's talk about a special matrix. So if we have a matrix A that consists of 1, 3, 1 in the first row, -4, 3, 2 in the second row, 1, 0, 1 in the third row, and a matrix, let's call it I, which consists of ones on the main diagonal and anything else is 0. So we want to see what is A times I if possible. This is possible because the order of matrix A is 3 by 3, matrix I is 3 rows by 3 columns, the inner numbers are the same, so we can multiply. And the resulting matrix is 3 by 3, 3 rows and 3 columns. Now let's multiply. We multiply the first row by the first column, and we multiply that. How to do that? We multiply the corresponding elements and we add. So 1 times 1 is 1, plus 3 times 0 is 0, 1 times 0 is 0, so we just have 1 here. Now let's multiply it by the second row. So we have 1 times 0 is 0, 3 times 1 is 3, and 1 times 0 is 0, so we only have 3 on the second first row and second column. Now we multiply it by the third column, so we have 1 times 0 is 0, 3 times 0 is 0, 1 times 1, 1. So that's the first distribution of the first row over the matrix I, the columns of the matrix I. And then we do a similar thing for the second row. So we multiply second row by the first row, first column, second column, and third column of I. So negative 4 times 1 is negative 4, and then 3 times 0, 2 times 0, those are zeros, and then we multiply it by the second column. So negative 4 times 0 is 0, 3 corresponds to 1, so we consider it, and then 2 times 0 is 0. Then we multiply the second row by the third column. So 1 times 0 is 0, 0 times 0 is 0, 1 times 1 is 1. And then we do same thing for the third row. So for the third row we need to multiply it first by the first column. So 1 times 1 is 1, 0 times 0, 1 times 0, those are zeros, and then we multiply it by the second column. So we have 1 times 0, 0 times 1, and 1 times 0, so that's 0. And then we multiply it by the third column. 1 times 0, 0, 0 times 0, 0, 1 times 1 is 1. Now that's the resulting matrix. Now if we look at this matrix, this is the same as our original matrix. So this is the same as the matrix A. So we got the matrix A. So that means the matrix I worked as an identity. It does not change anything. So when we multiply a matrix A by the identity, then that will not affect the multiplication. Same as the rule of the number 1 and multiplying different numbers. For example, when we multiply 5 by 1, we get 5 because 1 is an identity. It does not change anything. So same thing here, we have the matrix I. Now same thing is correct if we multiply from the left. I times A, still possible because the order of I is 3 by 3, the order of A is 3 by 3, and the inner numbers are the same, as you can see. So we can multiply and we get same thing. Please try this, and then you will find that the resulting matrix is A. So that's what we call identity matrix. So the matrix I is called an identity matrix. Now the identity matrix depends on the order of the given matrix. For example, if the matrix is 2 by 2, 1, 2, 3, 4, the identity will be 2 by 2 as well. So, but 1's on the main diagonal and 0's everywhere else. If the matrix is 4 by 4, then we have the identity matrix that consists of 4 rows, 4 columns, but everything is 0 except the main diagonal where we have 1's. That's the identity matrix. Okay. Now the last thing in this video is the matrix representation, and that's introduction to how to solve systems of equations using matrices. We learned Gauss elimination method previously. Now we have another powerful method that uses inverse of a matrix. We'll talk about it next time. So we have matrix representation, or sometimes called matrix form. Now what is the matrix form? Let's take an example. We want to write the following system of linear equations in matrix form. What do we mean by matrix form? Matrix form is the following form: A times X, we don't need the dot, we just write it AX equals B. This is called matrix form. What is A? A is the matrix of coefficients. And what is X? X are the variables that we have, for example, X, Y, and Z. And B, the matrix of constants. So for our example, we have the following system. We have 2x minus 4y plus z equals 6, and negative 3x plus 6y minus 5z equals negative 1, and x minus 3y plus 7z equals 0. So this is the matrix, the system that we have. We want to write it in the matrix form. So to write it in the matrix form, we need to determine the matrix A. The matrix A is the matrix of the coefficients. What are the coefficients? Here we have the coefficients of x, the coefficients of y, the coefficients of z. So we have 2, negative 4, 1, the first equation. The second equation gives negative 3, 6, and negative 5. And the third equation gives 1, negative 3, and 7. And we have the matrix of variables. The variables are x, y, and z. This is a column matrix. And the matrix B, or the matrix of constants, 6, negative 1, and 0. And then in order to write it in the matrix form, we need to write it as AX equals B. So we write it this way. A is 2, negative 4, 1, negative 3, 6, negative 5, 1, negative 3, and 7, times x, y, and z, the matrix X, equals the constant 6, negative 1, and 0. This is called the matrix form when we write it this way. If you want to check your answer, you multiply those two matrices. This is possible because the order of the first matrix is 3 by 3. The second matrix is a column matrix. It has order 3 by 1. The inner numbers are the same, so we can multiply.